In this video, I'll present our work AutoPreview, a framework for autopilot behavior understanding. First, I'm extremely thankful to collaborate with an awesome team, including Niviru Wijayaratne, Peter Du, SJ Jiang, and my PhD advisor Katherine Driggs-Campbell at UIUC. For safety concern, existing self-driving solutions in the market still requires human and self-driving car to collaborate together to ensure road safety. The success of this collaboration built on the assumption that human driver has already built a sufficient understanding towards autopilot behaviors. So for example, in terms of what scenario the system can go wrong. However, this assumption does not hold in practice. In the top figure, one Tesla driver complained about how the autopilot exits the highway unexpectedly, which can potentially cause serious car accidents. Our goal is to provide tools to help drivers to build accurate mental models towards self-driving behaviors. We introduce a simple but effective interaction to help human driver build mental model towards autopilot behaviors before letting the autopilot directly control the vehicle. This interaction is realized through a delegate agent that can inform the end user about the potential action of the autopilot based on the current observations. So for example, in the left figure, it illustrates how this interaction can help user understand what trigger condition would be for an overtaking actions. And the right figure describes how this interaction can reveal the trigger condition for a potential failure of the autopilot. Note that the proposed interaction happened before one self-driving driver deployed the systems, as shown in the figure at the top. This interaction timing can provide user with more information about black box autopilot system and thus make more informed deployment decision. Meanwhile, as illustrated in the right figure down below, the interaction also has the potential to reduce the dangerous periods due to the unfamiliarity of the autopilot behavior. We propose a high-level framework called AutoPreview to generate delegate autopilot in the previous slides. In particular, the target autopilot is the system that end user hopes to know its behavior. The delegate agent takes the current observation and output the potential action that the target autopilot would take if deployed. Note that the delegate autopilot will not execute those actions. Along with the proposed AutoPreview framework, we highlight two potential practical applications that this framework enables. One scenario is when there is a new release about the autopilot system that modify the control behaviors. So in that case, people need the behavior information to decide whether they should deploy this new released autopilot system to their car. The other scenario is during the initial purchase of a private self-driving car, when people want to know autopilot behavior in order to compare and decide which car model to buy. To show the feasibility of the proposed framework, we built a prototype for our AutoPreview framework in the CARLA simulation environment. In this video, the Eagle car is manually driven by a human driver, and the action table at the top will stream the potential action. Whenever there is an arrow shown above in the action column, it indicates a potential lane switching action that the autopilot would take at the current timestamp if deployed, given the current observation. In this preliminary study, we wonder whether our AutoPreview method can help users build an accurate mental model towards the self-driving behaviors when the control action is performed. Thus, we set up our experiment to compare against the baseline when the autopilot system directly controls the vehicles. So during the experiment, we record and ask participants to watch driving video clips, and in the post-experiment, we ask them to predict the earliest lane switching timestamp in 8 test scenarios. Here is a visualization of the two condition groups videos. In the treatment group, the participant learns about autopilot policy through the action table at the top, and in the comparison group, they directly learn from the Eagle car behavior, which is currently controlled by the target autopilot policy. We measure the degree of autopilot behavior understanding from driver deployment preference, perceived autopilot driving style, expected action timing, and the participant report prediction confidence for lane switching operation in 8 different test scenarios. From our experiment result, we found that the timing error for the participant prediction in the treatment group is much lower than those in the comparison groups, and both groups show similar aggressive level predictions. Even though the sample size is small, this preliminary study suggests that AutoPreview has the potential to build an accurate mental model towards autopilot behavior. So here are the 3 takeaways of our paper. We highlight a novel design space for autopilot behavior understanding that deserves more attention in the community. And we propose the AutoPreview framework together with 2 potential applications that this framework enables. Thanks for listening.